All right, so today we talked a little bit about kind of some advice you might give to an Algebra 1 student. And if you had, 2 points, one student thinks that it's impossible to write an equation with such little information. But in Algebra 1, you really did learn that, you can find out the m value by doing y2 minus y1. So m is y2 minus y1 over x2 minus x1. And let's say you got a number like 4, let's say, and that you knew that one of the points was like 7 and maybe 18. Those are my favorite numbers because it's also my birthday. But, once you have the m, you can plug the m back into the equation. So in this case, let's do it over here. We would get y equals, 4x plus b. And if we're looking for the b value, we could very easily substitute the x and the y into the equation so that it's 18 equals 4 times the x value, or 7, plus b, and then we could solve for the b. So 18 equals 28 plus b, and then subtract 28, and it looks like we get negative 10 equals b, so that we could write an expression for the b value and plug that in. So if we have the m and we have the b, then we can write the equation y equals 4x minus 10. And we can write that with such little information because we can substitute values into the function. Well, in Algebra 2, we can kind of do the same thing. And I want you to see that if we've got a function that has a vertex of -2 and 3, so -2 and 3, the vertex is right there, and a y-intercept, it intersects the y-axis at -1, and I'll do that here in blue, so the point 2, 3 is in red. In blue, we've got y-intercept is -1. Well, I hope that you can see that this is going to be a function that is a little bit upside down in order to have that vertex where it is. So just be prepared for this a value. Because it's upside down, we're expecting it to have an a value probably that's negative. If we don't get that, we've got problems. Okay, so I'm going to go ahead and move us up here. If we use our format, y equals a times x minus h squared plus k, we know that the x is the x-intercept is the h value, and the y of the vertex is the k value. So we've got y equals some unknown a value that we're going to find in just a moment, x minus, but the h is negative, so -2. We've got this double negative there, all of that squared, plus k, and the k was 3. So we've got our k being 3. Well, now I know another critical point. I know, I'm going to do that over here. I know, maybe I'll do it in green, I know it intercepts at -1. So we've got the coordinate 0 as the x-coordinate and -1 for the y-intercept. So we've got that y-intercept section that we know. So we actually do have an x and a y to be able to substitute into this equation down here. So we'll go ahead and do that. So instead of y, we know that y is -1 equals a, which we're finding, and we know the x value is 0. So 0 minus, we've got this double negative there, so it's really 0 minus -2 or 0 plus 2. 0 plus 2 squared plus 3. So all I've done here is I've taken another point that I know, in this case it's the y-intercept, and I've substituted it for the x and the y value and rewrote it. Well, this is just solving at this point. So we've got -1 equals a times 0 plus 2 is 2, so 2 squared plus 3. So that's really 4 times a plus 3 equals -1. I'll scooch up here. So then we're doing kind of opposite. So subtract 3 from both sides. So we get -4 equals 4 times a, and then divide by 4. So then we get -1 equals a. Well, here, I'm going to keep the h and the k that we had before. And remember, that's a double negative. And we're going to replace the a back in for the a. So we're going to use what we know. We know the h and the k of the vertex. So we got y equals a is -1. And we were expecting a -1. -1 times x double negative, so I'm taking this information and I'm putting it over here. So negative negative 2 is really plus 2. So plus 2 squared plus 3. And this is our equation for the graph that we described up above. We're going to do one more problem and then a practice problem for you. So take a look. We have the vertex. That vertex is very important because it can go in to our function for h and k. So minus h squared plus k. So we're going to start from the base. And our 1 and negative 4 is our h and our k. So we're going to replace that in the equation. So y equals a times x minus 1, because h is 1, squared plus k, and k is negative 4, so I guess we have to make that a negative 4 for k. And then I have another special point. It's negative 2 and 1, and we're going to put that in for the x value and the y value. So we really think here that, 1 equals some value a times the x value, which is negative 2, minus 1, quantity squared, minus 4. So I'm just kind of copying everything else down. And then it's a solving game. So 1 equals a times negative 3, quantity squared, minus 4. Negative 3 times negative 3 is 9. So we've got a times 9, so minus 4. 1 equals all of that. So I'm going to just solve it. So plus 4, plus 4. So we got 5 equals 9 times a, or a times 9. It doesn't really matter. And then we're going to divide both sides by 9. So we've got this funky fraction. So a equals 5 over 9ths. But it's correct. And we're going to plug that a. Maybe I'll grab a highlighter here. We're going to grab that a, and we're going to put that in for the a in the equation with the vertex. So we're going to take this, and we're going to mend it. We're going to amend it. So y equals the 5/9 that we had before times x minus the x coordinate of the vertex, so 1 squared minus 4, the y coordinate of the vertex. And this is an equation. If I were to graph this thing, I would hope that, in my xy graph, the vertex would be at 1, negative 4. So the vertex would be there, and the y-intercept, and then our other point is negative 2, 1. So our other point, negative 2, 1. I would expect that if I were to graph this like on a calculator, it would look kind of sort of like this, because it's going to go through that vertex point and through the point that we decided. There's one more that I think that you should try as practice. So during an Olympic race, there's a software that actually measures the peak height of the ball to be 20 feet after 1 second. And so really, if we're thinking about, if we've got time and height, we're thinking, okay, 1 second after the ball, it has a height of 20. So 1, 20 is the coordinate there. This particular ball was hit 4 feet off the ground. Well, it's hit at time equals 0. So time is 0, height is 4. It looks like we've got a curve of this ball, and I hope that you can see how this came to be. We could probably predict where it lands even. But if we're going to write an equation, you know some critical piece of information. You know the vertex, and you actually know another point, the starting point. So go ahead and try and write an equation from this. Real quickly, I made a quick mistake here. This should be negative 16 equals a. I hope this video was helpful. Thanks for watching.